Alright, so today we're going to look at finding the formula to graph the sinuside for these data points shown here. So the way I set out doing this is first we have to figure out the amplitude, the period, and the midline so that we can find parameters for our function a, b, h, and k. So to find the midline, first we need to find the minimum and the maximum points. So out of all of these data points, this June 21st is going to be our maximum, and December 21st is going to be our minimum. So our midline is going to fall directly in between 9.07 hours and 15.27 hours. So calculating that out, our midline is equivalent to 12.17 hours, as shown by this red line going through here at y equals 12.17. Next, I'd have to find the amplitude, because that's directly equivalent to that directly shows what our a value is going to be. The amplitude is the difference between the maximum and the minimum from the midline. So 15.27 minus 12.17 is 3.1. So that's our amplitude. And our period is going to be a whole year because we're looking at daylight data for a whole year. So it's just going to be 365 days. 365 days. Alright. So to graph the sinusoid, we can use two functions. We can use y equals cosine of x, or we could use y equals sine of x. Because y equals cosine of x starts at its maximum and decreases, and our data starts at our minimum and increases, I'm going to go with y equals cosine of x. So see, this makes sense because if we make our a value negative, it'll flip the graph of y equals cosine so that it starts at its minimum and increases, like the graph shown here. So our a value is going to be negative, and it's equal to the amplitude, so it's 3.1. Our b value is equivalent to 2 pi over our period, which is 365. And this can't be simplified further, so our b value is equal to 2 pi over 365. Now, our x values our 0 is December 1st, so this is days after December 1st, going from 0 to 365, so 365 would be December 31st of the next year. So our minimum is at December 21st, which is 10 days before our 0, so it's going to be right here, and that's going to be our minimum. It's also going to be our starting point, so our h shift, our horizontal shift, is going to be negative 10 days. And our k value is going to be our vertical shift, how high we push up our graph. So over here is going to equal our midline, because for y equals cosine, the midline is 0, because it passes straight through. For this one, the midline is 12.17, so our entire graph is going to be pushed up 12.17 units. So using our form for sinusoid functions, for transformed sinusoid functions, we know that y equals a cosine of b times x minus our horizontal shift plus k. So plugging all these values in for a, b, h, and k, we get that y equals negative 3.1. Remember that negative flips our graph, so it starts at minimum and increases. Cosine of 2 pi over 365 times x plus 10. Keep in mind that since our h is negative, it's minus 10, so it becomes positive 10. And then add 12.17. So this graph, this formula would give you the graph that describes these daylight patterns for the entire year. So yep, there's the amplitude period. Amplitude, remember, is 3.1, and our A value is -3.1, and our B value is over here, and it's 2 pi over our period, which is 365. Our H is horizontal shift. We're pushing our graph to the left by 10 units, and our K pushes our graph up by 12.17 units. So yeah, this is the formula for the sinusoid graph that shows this data.